So let's start. Now, since I've opened the notes right now, I'll just show you, I'll give you a brief introduction. How are radio waves produced? We have discussed this. The different components of the electromagnetic wave, we हम लोगों ने discuss किया हुआ है. Polarization we have discussed. We have just gone over circular polarization. We have understood what is time period, frequency, wavelength, amplitude, and speed of light. And we have also discussed this formula, right? Apart from this, we have also discussed what is the speed of light, reflection, diffraction, and how does total internal refraction take place. Today I'm going to teach you what is phase difference and the different frequency bands. Okay, this is one thing that was I had purposefully left it from the previous chapter. I wanted to teach you these things. Okay, propagation theory, attenuation, and everything. Today I'm going to go through these two parts. It is a very simple thing. It is a very simple thing, and I will then go through radio propagation paths over here. We have done this part. This is chapter number 2. We have done about attenuation. We have done attenuation. We have done absorption, reflection. We have done static interference. We have done fading. Okay. Is anyone here who wants me to redo or re-go through these things? No, right? So let us start. So the topic for today is phase comparison or phase. Okay, if you have enough space in your notes, you may also write this down. You may also write this down where you were writing down about phase. Okay, what is phase? Phase is the angular position of a wave. Phase. Phase क्या है? In simple one word, if I were to teach you about phase, it is the angular position of a wave, correct? Now phase can be compared. Phase can be compared. Let's say I have this thing. So let's say this is a reference wave. This is a reference wave. Okay. The reference wave की speciality is what? It always starts from the origin at 0. It always starts from the origin at 0. Okay. Great. Now, even though it starts from the origin at 0, let us have another wave. Let us have another wave. Let's say somewhat like this. This is called the variable wave. This is called the variable wave. ये कुछ ऐसे दिखता है. Okay. Somewhat like this. Are they both in phase with each other? Are they both in phase with each other? No, right? Are they both in phase with each other? Like this? No, they are not in phase with each other. They are somewhere out of phase or just not perfectly overlapping each other. Correct, Vandana? क्या एक दूसरे को ओवरलैप कर रहे हैं? नहीं. देखो, this guy over here in 0 degree phase पे. Blue वाली is the reference wave. Blue वाला is the reference wave. And the green one is the variable wave. So what is phase comparison? Phase comparison is basically we are comparing the phase. We are comparing the phase of two different waves. We are comparing the phase of two different waves. Let's see how. Let's see how. This axis is the time axis. Let us take at any given point of time. Let us take this time. Okay, this time. This is a time segment, and at any given point of time, मैंने photo उठा ली. I took a picture of the wave. Okay. At this point, the reference wave is at what phase, Vandana? ये कौन सा phase है?
90.
Very good. This is a 90 degree. Everyone agrees? Yes. Variable wave कौन सा phase पे, Vandana?
90.
Variable green वाला. ये वाला.
45.
नहीं. It is passing the origin. It is passing the mean position. What do you think?
0.
0. Okay. Any doubts?
No.
Very good. So this is at 0. Vandana, what is the phase difference over? What is the phase over here? This is also at the origin. So this is also 0. No, this is not 0.
This is
This is not 0. क्यों वंदना? Because एक साइकिल जो होता है उसमें
180.
यस 180. क्यों? क्योंकि ये देख, ये भी ओरिजिन पे, ये भी ओरिजिन पे, लेकिन ये ऊपर की तरफ जा रहा है तो ये 0 डिग्री है. ये नीचे की तरफ जा रहा है, सो दैट इज व्हाई इट इज 180 डिग्रीज. Okay, everyone okay? So I have to basically understand what is the phase difference between them. The variable wave is at 0 degree phase, the reference wave is at 90 degree phase. Is the phase different? Yes, it is different. So I should be able to calculate what is the phase difference. Phase difference. Phase difference has a very unique formula, and that not very unique formula. It is called the reference minus variable. Whatever is the phase of the reference wave, subtract the variable wave ka phase difference phase. Okay, so what is the phase difference between them? Reference wave is 90, variable wave is 0, so phase difference is equal to 90 degrees. Now Sriram has a doubt. Everywhere. So if the phase difference is over 90 over here, what about this place, Ankit? What about this place? Is the phase difference 90 here also? वंदना, अगर मैं थोड़ा आगे चला गया वेव में तो ये ब्लू वाला पॉइंट है, यहाँ पे भी 90 डिग्री फेज होगा, फेज डिफरेंस. चलो देखते हैं, है ना? So I take this line, Vandana takes this line. What is the phase over here, Vandana, of the blue wave, of the reference wave?
360.
360 or 0, same thing. Everyone agrees. What is the phase over of the green wave, Vandana? The variable wave. ये वाला
180.
नहीं,
270.
गैस कर रही है?
नहीं.
एक आंसर कंफर्म करके बता फटाफट.
270.
पक्का लॉक कर दिया जाए?
हाँ. Yeah.
क्यों है 270? Why is it 270? सही आंसर है. क्यों? कैसे?
साइकिल एक साइकिल में फिर ऐसा होता है.
हाँ, नीचे की तरफ. तो ये वाला 270 है ना? वेरी गुड, याद है तेरे को. देख, सब बोल सकती है तू. सो 360 या फिर 0, एनीथिंग यू कैन राइट, एंड दिस इज 270. सो अगर इफ आई सब्ट्रैक्टेड एट दिस पॉइंट आल्सो, आई विल गेट 360 minus 270. Again, this is what? 90. Wherever I find this thing, the phase difference will be the same. But I can only compare the phase difference. I can only calculate phase difference. Phase difference can only be calculated that when you have one particular thing. And this can only be calculated if the frequency is the same. Now imagine, can I calculate the phase difference between a wave which is going like this and the phase difference between a wave which is going like this? No. Vandana? Vandana? मैं फेज डिफरेंस कैलकुलेट ही नहीं कर सकता अगर फ्रीक्वेंसी सेम नहीं है. इफ द फ्रीक्वेंसी इज नॉट सेम, आई कैन नॉट कैलकुलेट द फेज डिफरेंस. ओके, एनी डाउट्स? श्रीराम, so
This variable wave
अगर इधर
is
one second Vandana, one second. Shriram, tell me.
the variable wave like always starts from here, or its position keeps changing?
Variable, the word is variable. Any, it can start from anywhere. Okay, we'll do numericals on this. Vandana, tell me.
the same term.
वेरिएबल वेव कहीं से भी स्टार्ट हो सकती है, बट आई कैन ओनली कंपेयर इट व्हेन द वेरिएबल वेव इज ऑफ द सेम फ्रीक्वेंसी एज द दिस वेव, रेफरेंस वेव. ठीक है, दिस इज अ रिक्वायरमेंट. तो अब देखो ये वाली आपकी वेव है, ठीक है. लेट्स से आई हैव दिस वेव, so I can compare it only if they both have the same frequencies, right? Like this, they both have the same frequencies. Okay, there is another thinking, there is another way to think about phase difference. Okay, and that thinking says ki okay, if okay, for example, like this is 90 degrees of phase difference. So ye 90 degree phase difference kaise hua? How did this become 90 degree phase difference? Okay, I have this reference wave. Okay, I have this reference wave and I have this variable wave. Now these both waves, they are in phase. Okay, kind of like this. If I tell you that the wave is over here, that the wave, instead of like being like this, it is like this, so they are opposite phase, right? Now tell me, if I tell you okay, they are like this, so this wave is 90 degrees ahead, this wave is 90 degrees ahead. What is the phase difference? 90 degrees. Now I put this again more in front. Now it went 180 degrees ahead. देखो क्या हो रहा है वंदना, एक चौथाई आगे गया, एक चौथाई आगे गया. It went 90 degrees ahead, 1/4 it went ahead, again 1/4 it went ahead, so 180 degrees it went ahead. Now one more, kind of like this. This can also be thought to be like this, huh? So it went 270 degrees ahead. It went 270 degrees, and this again it went 360 degrees ahead, so it overlapped. So phase difference ka another way of thinking is what? By how much is the variable wave ahead of the reference wave. I can also think of it like this. मैं ऐसी भी thinking रख सकता हूँ, है ना? वंदना, फरहाद, अंकित, श्रीराम, ऐसे भी थिंकिंग रख सकता हूँ कि वो कितना आगे है. ओके, अंडरस्टूड? एनी डाउट्स? Now this was about phase and phase difference. Now let us talk about bands. Let us talk about bands. Please make a note with me. Name of band. So I taught you about the electromagnetic spectrum, and in that electromagnetic spectrum, the light we can see that is very small part of it, है ना वंदना? जो हम लोग लाइट देख सकते हैं वो एक उसका बहुत छोटा हिस्सा है. अब जहां से आप इसके यहाँ पे जाते जाओगे, आप फ्रीक्वेंसीज इसकी कम करते जाओगे, व्हेन यू कीप ऑन रिड्यूसिंग द फ्रीक्वेंसीज, यू विल कम टू दिस बैंड कॉल्ड द रेडियो वेव्स. दिस इज आल्सो अ बैंड. Now I told you, remember, this band has subparts, subbands also, which have different properties. Let us talk about those bands. Okay, so radio waves, actually, when I taught you this chapter, I was teaching you about radio waves. So radio waves essentially exist from 30 or 3 kilohertz to 300 gigahertz. ओके सो ये फ्रीक्वेंसी बैंड कहाँ से है फ्रॉम 3000 हर्ट्स टू 300 000 000 hertz. This much. This is a very wide spectrum. So this very wide spectrum also will have bands. Huh? This also will have bands. Let us talk about these bands. So all of these scientists, na, radio navigation, all of these scientists, they are very, very buddhu scientists. They are not creative people. They are not creative people. Okay, Vandana? So they were like, okay, 1, 2, 3, 4, 5, 6, 7. Eight bands. Okay. They are very, very stupid. So I'll show you how. You firstly have something called the VHF. Okay. You have something called the VHF. It is the fifth one. Very, or let's say we'll talk about something in between, high frequency. High frequency. The short form is HF. The HF band. I'm only talking about names over here. Huh? Vandana, if something is high, what is the opposite of high? Low. So they kept this as low. Low frequency. Or also known as LF. What is between low and high, Vandana? Middle. Middle frequency. See, no creativity at all. Also called MF. What is, okay, now everyone knows these three. Everyone knows these three. What is below low frequency? Very low frequency. No creativity at all. VLF. What is above high frequency? Very high frequency. VHF. What is above very high frequency? Ultra high frequency. This is no joke, huh? This is no joke. These are very important words. I'm teaching it to you in a fun way, but these are very important words. You will get confused between all of them. आप बाद में जाके इसके अंदर confused हो जाओगे. Please remember all of these very well. This is no joke. Okay? Then ultra के बाद आता है Superman, super high frequency. SHF. And lastly, you have EHF, extremely high frequency. Now, all of these are what? All of these are what? These are all bands. So all of these bands will have a range. All of these bands will have a range. So let us talk about the next line or column, the frequency range. The frequency range. It is very simple to remember this. It is very simple to remember this also. But प्रॉब्लम ये क्या है, आपको हर बार ये डायग्राम बनाना पड़ जाएगा अगर आपको याद नहीं रहती हैं पिक्चर्स. सी इट इज लाइक 3 to 30. Add 1 0. Now if this ends at 30, this will start at 30. Add one other 0, 300. And this again then starts at 300 and add another 0, 3000. Okay? Any doubts? Okay, so I'll take this. ओके, बट व्हाट, यूनिट भी तो होना चाहिए, यूनिट भी तो होना चाहिए ना वंदना. व्हाट इज द यूनिट? द यूनिट इज किलोहर्ट्ज. किलोहर्ट्ज, kilohertz, kilohertz, kilohertz. Okay, but what is 3000 kilohertz, Vandana? What is 3000 kilohertz, Farhad?
सारे आ गया था
3 megahertz. Vandana, 3 megahertz क्या होता है? 3 किलो 3000 kilohertz को मैं 3 megahertz बोल सकता हूँ.
हाँ.
कैसे? आपको ये आता है, इसका कॉन्सेप्ट आता है पीछे का?
हाँ.
कैसे?
मेगाहर्ट्ज.
चलो बताओ वंदना, व्हाट इज, अगर मैं आपको बोलूं 3000 मेगाहर्ट्ज है तो क्या बोलोगे?
मेगाहर्ट्ज से अगर किलोहर्ट्ज में कन्वर्ट करना है तो मल्टीप्लाई.
नहीं, मैं देख, मैंने पूछा तेरे पास 3000 किलोहर्ट्ज था, है ना? 3000 किलो, तो आपको क्या मिला? 1 मेगा मिला, है ना? क्या वंदना?
हाँ.
अगर मैं बोलूं तेरे पास 3000 मेगा है तो क्या मिलेगा?
3 गीगाहर्ट्ज.
वेरी गुड, वेरी गुड, राइट आंसर. एवरीवन अंडरस्टैंड? So I can also write this as 3 megahertz. Now I will again start from 3. I will again start from 3. Copy, paste, change. Okay, and I will just remove what? Kilohertz को हटा दो and write megahertz. Simple. Ankit, 3000 megahertz is what? Very good. So now next one will again be 3 to 30 and 30 to 300. What? Gigahertz, 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 gigahertz. Okay. So this is the frequency range. This is the frequency range. Any doubts in the frequency range? Now, if you have a frequency range, they will also have a wavelength range. They will also have a wavelength range. Okay, let us calculate that also. Very fun. थ्री किलोहर्ट्ज का कितना होता है? कैलकुलेटर लो. You don't have to do any rough work. Just take out your calculator and you have to convert this frequency into wavelength. 3 kilohertz. How can you do it? You simply take 300, है ना? और नीचे क्या आएगा? 3 किलोहर्ट्ज आएगा. तो 3 किलोहर्ट्ज को मैं कैसे लिख सकता हूँ मेगाहर्ट्ज में वंदना? 0.003, है ना? किलो को मेगा में कन्वर्ट करने वंदना क्या करूंगा मैं? डिवाइड बाय 1000 करूंगा ना. तो कोई भी चीज छोटी हो जाएगी ना 3 से, 0.003 हो जाएगा. समझी नहीं समझी? यहाँ मत्थे के ऊपर से क्या?
नहीं समझ.
300 divided by 3 kilohertz. But Vandana told me that we cannot put 3 kilohertz. Sir, why? Because in the formula we have megahertz. Right? So I have to convert this into megahertz. How can I convert this into megahertz? Divide this by 1000. So you will get 0.003. Put this in your calculator. What do you get? 100. Do you get this value? Do you get this value? But this is in meter. So this can be 100 kilometer. अब देख यहाँ पे, देख इसका एक जीरो बढ़ गया. वंदना देख यहाँ पे इसका एक जीरो बढ़ गया. तो ये क्या हो जाएगा? यहाँ से यहाँ तक जाएगा तो ये 10 किलोमीटर हो जाएगा. एक जीरो कम हो जाएगा, है ना? फ्रीक्वेंसी बढ़ी, वेवलेंथ उतने से ही कम हुई, है ना, स्मार्ट मूव था ना, कैलकुलेट करने का जरूरत ही नहीं पड़ा मेरे को, वंदना देखा. देन अगेन ओवर हियर दिस इज 10 किलोमीटर टू 1 किलोमीटर. अब 1 किलोमीटर है, आई विल कॉल इट 1 किलोमीटर से लेके 100 मीटर, बिकॉज दिस कैन ऑल्सो बी रिटन एज 1000 मीटर्स, है ना. समझ आ रहा है वंदना? 100 meters to 10 meters, and then 10 meters to 1 meter, then again 1 meter, या फिर इसको मैं क्या बोल सकता हूँ, 100 सेंटीमीटर से 10 सेंटीमीटर, 10 सेंटीमीटर से लेके 1 सेंटीमीटर, एंड इधर 1 सेंटीमीटर से लेके 1 मिलीमीटर. देख 10 10 10 10 10 10 10 से डिवाइड हुआ. ओके, so imagine radio waves are that big where one wavelength can be of 10 kilometers or even 1 kilometer. एक किलोमीटर कोई है? डू यू रिमेंबर वंदना? डू यू हैव अ फ्लाईओवर इन योर सिटी that is over 1 kilometer long? No? Any road that you know is 1 kilometer long? Can you, है ना? तो इमेजिन करो एक रेडियो वेव जो पूरा एक साइकिल कन्वर्ट करे, and it takes that much amount of distance. Imagine कितना बड़ा, that big. We also have radio waves which will complete one cycle in only 1 centimeter, this much. See the expanse of radio waves. See the expanse of radio waves. It is a very big expanse of radio waves. Do you guys understand this now? So all of a wave which is traveling that big steps will not have the same properties as a radio wave which is traveling with this small steps. Okay, they will be different, and we are going to study about such waves. Any doubts so far? No, right? Okay. Take a quick 2-minute break. Take a quick 2-minute break. I will meet you in 2 minutes. Any doubts in this?
Can you scroll above the wavelength and copy?
Okay. Drink water, get freshen up. I will now teach you surface waves. आ जाओ सारे आ जाओ। अच्छा, इसके ऊपर ना देयर विल बी अ फ्यू न्यूमेरिकल्स बेस्ड ऑन द फ्रीक्वेंसी, इज इट मेट्रिक, is the frequency decimetric, is the frequency kilometric, is the frequency hectametric. I will do it, I will teach it to you when I, ठीक है, and I start off with your questions. Okay, any doubts? तो अब मैं आपको surface waves, sky waves वगैरह सिखाने वाला हूँ. I'll just go over through the notes once. वंदना वीडियो ऑन कर ले यार. वंदना, Vandana, how do you read? वीडियो ऑन करो यार.
अब आ रही है आवाज?
कट कट के आ रही है यार वंदना.
अब सही है?
अब सही है. ठीक है, तो लेट अस टॉक. अच्छा, इसके थोड़े न्यूमेरिकल आते हैं, जो मैंने आपको ये वाला चीज कराया ना, देखो न्यूमेरिकल बेस्ड क्वेश्चन इसके ऐसे आते हैं. आई विल टीच दिस टू यू व्हेन आई टीच यू अबाउट न्यूमेरिकल, जहाँ हम लोग बाली या ऑक्सफोर्ड अगर चलेंगे तब करेंगे. वंदना म्यूट कर लो. ठीक है, नाउ यूनिट कन्वर्जन. एक बार जस्ट इसको देख लो, जस्ट मेक अ नोट ऑफ दीज यूनिट कन्वर्जन्स प्लीज. These will come in handy. Just make a quick note of it. Fadafat. Raise your hands once you have made a note of it. Farad, done? Vandana, Shriram? करें, शुरू करें, कंटिन्यू करूं? वंदना डन? ठीक है, चलो. नाउ टॉकिंग अबाउट प्रोपगेशन थ्योरी, हम लोगों ने ये भी देख रखा है. वी हैव आल्सो स्टडीड दैट what are the different factors affecting propagation. Firstly, we have attenuation. What is it? It is the loss of signal strength. It can be due to two things. It can be due to two things. Next, secondly, we have also studied about absorption. We have studied about reflection. What happens and how does it get reflected and how does it get absorbed. We have also done about station interference. How is station interference produced due to other radio waves or due to other transmitters or due to natural phenomena like lightning and static charge buildup in the atmosphere. Okay, we have also studied about fading. This is the diagram through which you can explain fading to everyone. And this is the same diagram that you should be able to explain it to the examiner with the help of your hands and any given obstacle. Okay, you have to talk about the phase difference. You have to talk about the phase difference at the point of reception. They may or may not reach at the same phase. If they reach at the same phase, constructive interference, out of phase, destructive interference, and so on and so forth. Directivity and power will be covered in a later chapter of antennas. Okay. Now, talking about the different types of propagation. Propagation paths are of the following types. This is where we stopped yesterday, and this is the same place where I'm going to continue from today onwards. The revision for last day is done. Now I'm going to teach you the coming forward steps. You have something called as the, write down with me, propagation paths. The first and the lowest type of frequencies that actually propagate, they propagate via surface waves. And this surface wave, it is a non-ionospheric propagation. It is a non-ionospheric propagation. Ionosphere has nothing to do with it. So talking about surface waves, this is the first thing, surface wave, and we are going to study about this right away. Okay, I have made you draw this diagram once beforehand also, but I will not draw it again. I will simply go and teach you straight about surface waves. So what are surface waves, guys? Please have a look. Put down the heading as surface waves. Let us say we have Mother Earth. We have Mother Earth. Earth is a blue planet. So this is Earth. And the thing that you're seeing on the screen is the curvature of the Earth. Anywhere on the surface of the Earth, I put up an antenna. And this antenna, I give them a frequency. On the lower frequency side. On the lower frequency side, I give them a frequency. Okay? On the lower frequency side, I give them a frequency. It was naturally observed. It was observed by the scientists. Scientists लोगों ने observe किया कि इसमें से जो भी wave निकलती है ना, ये waves should ideally, ये क्या electromagnetic disturbance है ना, ये electromagnetic disturbance, this electromagnetic disturbance should travel in straight lines like this. But it is observed that they don't travel in straight lines. What do? They bend. Now, why do they bend? They bend because of something known as diffraction. Okay? Surface waves, first point, follow Earth's surface. Follow Earth's curvature. Why? Due to diffraction. What is diffraction? Remember I told you that this will come in handy on a later class? Yes. So what is diffraction? Diffraction, let's say there is an obstacle and you have a light source and it is coming and hitting the edge of the light. At the edge of the obstacle, this light wave will not only go straight, but it will kind of also bend. This will kind of also bend. This will kind of also bend towards the obstacle side. But now look at this Earth. This frequency. Now see, the lower the frequency ना, जितनी कम frequency होगी, the lower the frequency, जितनी कम frequency उतना वो लल्लो लाल, वो bend हो जाएगा, उतना weak. It will have more tendency to bend. If I have a wave which is very very strong, more than 50 megahertz, more than 50 megahertz, it will not bend. Okay, anything below 50 megahertz is BPL. They can bend. Okay? So this is a wave and it will follow the surface of the Earth. This disturbance will follow the surface of the Earth. Why? Because see, it wants to go in this direction. But we have Earth an obstacle. Okay? This guy, he wants to go in this direction. He wants to travel in a straight line. But Earth is an obstacle. So it will bend around the obstacle. Again, he sees Earth is an obstacle, so he will bend around an obstacle. Again, Earth is an obstacle. It faces diffraction. It again keeps on following the surface of the earth like so. Understand? Understand? वंदना, कोई समझ आया? कोई भी चीज ऐसी जो नहीं समझ आई? अब आप बोलोगे यार तो भैया मेरे को एक बात बताओ, इफ आई एम स्टैंडिंग ऑन द सरफेस ऑफ द अर्थ, क्या वो सांप की तरह मेरे पैरों के बीच से जा रही रेडियो वेव? Is it going like a snake above my legs? No. You have to understand that these are waves with a very, very high wavelength and a very, very low frequency. The wavelength of these waves is up to 1 kilometer. Okay, so these are very, very long wavelengths and very, very low frequencies. Okay. Now it was observed that if I take an antenna, and if I put in frequencies in this antenna from what? From 20 kilohertz all the way up till 50 megahertz. All the way up till, make a very big line. Huh? All the way, this is a very big line. Make a big line. Make it till 50 megahertz. All of them show surface waves. All of them, some part of it, at least some part of it will travel as surface wave. There will be surface waves present. There will be surface wave present. Okay, but it is also observed. Okay, Sri Ram ka network is gone. We'll just wait for a minute. Sriram, can you hear me?
Yeah, now I can hear you.
So now let us talk about its attenuation. I can teach you about frequency only when I teach you about attenuation. So first, to learn about frequency, we need to learn about attenuation. Everyone knows what is attenuation. It is the loss of signal strength. But attenuation can also be dependent upon a number of things. Okay, for this type of mode of transport, for this type of propagation, there is more attenuation if there is more frequency. If the frequency is increased, then the attenuation also increases. If the frequency has increased, then the attenuation also increases. Okay? Understood? So I can say that frequency is directly proportional to attenuation. है ना? Frequency is directly proportional to attenuation. समझी वंदना? जितनी ज्यादा तेज एक कोई अगर वंदना अगर कोई वेव है जिसकी फ्रीक्वेंसी बहुत कम है, ऐसे 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 ऐसे, तो क्या वो उतना जल्दी आसानी से एटीन्यूएट होगा? नहीं होगा. अगर कोई वेव है विच इज गोइंग लाइक दिस, क्या ये बहुत जल्दी एटीन्यूएट होगा? हाँ, बहुत जल्दी इट विल लूज इट्स स्ट्रेंथ. So this is what I have written over here. As the frequency increases, the attenuation also increases. As the frequency increases, the attenuation also increases. Okay? Any doubts? तो अब देखो, यही चीज हम लोगों ने फ्रीक्वेंसी में नोटिस किया. यार ये सारी फ्रीक्वेंसीज, ऑल ऑफ दीज फ्रीक्वेंसी propagate as surface waves. But not all of these frequencies are efficient, because we noticed as I'm going from 20 kilohertz and I'm increasing the frequency, what is happening? As I'm increasing the frequency, these later part of the waves, this later part of the band, the more frequency part of the band, they're not giving me good performance. Why? As an antenna, it is going. Oh fuck! Wave got over. It got attenuated. It lost all of its strength. Khatam. So it was observed that the latter part, that means the higher part of this band, is not very efficient for propagation via surface wave. जो दूसरा वाला आगे वाला पार्ट है वो उतना एफिशिएंटली सरफेस वेव की तरह प्रोपेगेट नहीं कर सकता. एक और है उसके उसमें प्रोपेगेट करेगा बट सरफेस वेव की तरह प्रोपेगेट नहीं करेगा. ठीक है, समझ आ गई बात. तो even though you have surface waves present all across this band, but it is used operational. You can have all of it, but operational you only have from 20 kilohertz to somewhere in between. This is 2 megahertz. This is the green band. Like, okay, you will get good range also over here. Above this, using it as surface wave is not a very good idea, because above that frequency is so much that we wanted the surface wave to go here, but it is getting died down here only, so it is not giving me range. It is giving me what, 1 kilometer, 5 nautical mile range it is giving me. I don't want these things. Getting it. So this was about surface waves. And surface waves range is also dependent on something. So we spoke about attenuation. Now we will speak about range. The range of surface waves is dependent upon power. Every antenna is connected to a power line. तभी तो उसके अंदर रेडियो वेव आएगा, है ना वंदना? Every antenna is connected to a power line, then only it can put radio waves. So every power line that it is connected to, it will at least put in some power, electrical power, right? If you put in a lot of electric power, the radio wave coming out of the antenna will be a very strong electric wave. If you put in a very, very weak electrical power signal, the radio wave coming out of the antenna will be a very weak electric wave. So the power with which the antenna transmits is of very, very high importance. One second. Okay, so it is also dependent upon power. What power ka what? Sure. See. Please make a note that power is directly proportional to range squared. What does this mean? This means that अगर मुझे रेंज को 2 गुना करना है, if I want to increase the range by 2 times, Vandana, if I want to increase the range by 2 times, look what is happening. I remove the square, it will become 4r squared. So I have to increase my power by 4 times. Getting it? R squared क्या था? What was R squared? P was equal to R squared, na? Now I wanted to increase my range. I made it 2r squared. 2r whole squared. So it became 4r squared. What is r squared? 4r squared is what? P. 4p. And r squared was what? P. R squared क्या था? P तो था. What was r squared? It was P only. So if I want to double the range, I need to increase power by 4 times. Think. So iska meaning is what? Write down. The meaning of this is very important. That to double the range, I need to do what? क्वाड्रिपल का मतलब क्वाड मीन्स 4, quadruple the power and to half the range, 1/4 the power. In the exam you will get questions like, okay, 100 watts of power is giving me a range of 100 nautical miles. What should be the power if I want 200 nautical mile range? What should be the power if I want 50 nautical mile range? Give me answers. $425. Okay. Let's see if others think it is correct or not. And also tell me what will happen if your range becomes 300 and what will happen if it becomes 400. It will increase
एक
by
बार
square.
वापस रिपीट करो,
हाँ बता.
क्या करना है?
जोन आउट हो गई थी. ये समझ आया? ये वाला स्टेटमेंट समझ आया आपको?
हाँ,
नहीं
ये
समझ आया? बताओ.
4P वाला समझ में। एक बार
क्या?
सिखाओ वापस।
ठीक, अभी सिखा देता हूँ. मेरे को 1 मिनट दो. हाँ देख वंदना, जो पावर होता है ना, ये रेंज के स्क्वायर के प्रोपोर्शनल होता है. कहने का मतलब क्या वंदना, देख, मैं तेरे को अगर 1 कप दूध दूंगा तो तू 100 मीटर की रेस दौड़ेगी. ठीक है? भैया क्लास में हूँ मैं. 2 बजे मैं एंड करूंगा, फिर करते हैं ना. ओके. ठीक है वंदना, देख, जो रेंज है ना वो पावर के प्रोपोर्शनल है. अब दूध क्या है? दूध पावर है. अब आप कितना तेज, कितना दूर दौड़ोगे वो रेंज है. ठीक है? अगर मैंने आपको 1 ग्लास दूध दिया तो आप कितना दौड़े? 100 मीटर दौड़े. ठीक है? अब अगर आपको लगेगा, अब आपको लगेगा कि यार अगर मेरे को भैया 2 ग्लास दूध देंगे तो मैं 200 मीटर दौड़ूंगी, 3 ग्लास दूध देंगे तो मैं 300 मीटर दौड़ूंगी. लेकिन ऐसा नहीं है. अगर मैं चाहता हूं कि आप 200 मीटर दौड़ो, मेरे को आपको 2 नहीं 4 ग्लास दूध देना पड़ेगा. रेंज मेरे को 2 गुनी अगर करनी है तो मुझे आपको पावर 4 गुनी देनी पड़ेगी. समझ आई? ये फॉर्मूला का मतलब ये है. सी रेंज, इफ आई देख, रेंज का स्क्वायर है ना. अगर मैं चाहता हूं आप 300 मीटर दौड़ो, मेरे को आपको 9 ग्लास दूध देना पड़ेगा. स्क्वायर क्या? स्क्वायर. अब अगर इसको नीचे भी कर सकते हैं अपने, बढ़ा दिया ना. अगर मैं चाहता हूं भाई तू 50 मीटर दौड़, आधा, तो मेरे को क्या आपको आधा ग्लास दूध देना पड़ेगा? नहीं, 1/4 देना पड़ेगा बस. क्योंकि 1/2 जो होता है, हाफ का स्क्वायर रूट कर दो, सॉरी हाफ का भी स्क्वायर कर दो, तो क्या हो जाएगा? 1/4 हो जाएगा, है ना? तो 1/4. समझी? जो भी होगा रेंज के साथ, जो भी होगा पावर उसका स्क्वायर हो जाएगा. ठीक है? ऐसा साइंटिस्ट लोगों ने ऑब्जर्व किया एंड दे अंडरस्टूड दैट इफ आई वांट टू इंक्रीज द रेंज, सो आई हैव एन एंटीना, उसमें से एक इलेक्ट्रोमैग्नेटिक वेव निकलेगी. आई नीड टू गिव इट सम पावर ना. मेरे को उसको कुछ पावर देना चाहिए, तभी तो ये दूर जाएगी, नहीं तो दूर नहीं जाएगी ये. अब अगर मैं इसको जितना ज्यादा पावर दूंगा उतना ज्यादा दूर जाएगी. इफ आई वांट टू, इसका जो रेंज है मान लिया 100 मीटर जा रही है, अगर मेरे को इसकी रेंज को डबल करना है तो मेरे को पावर क्या करना पड़ेगा वंदना?
डबल करना, क्वाड 4 बार।
वेरी गुड। अगर मेरे को इसकी रेंज 3 गुनी करनी है तो पावर कितना करना पड़ेगा?
1/4।
अरे 3 बार करनी है, 3 टाइम्स। 100 मीटर था, 300 मीटर करना है, तो पावर कितना होगा?
हाफ होगा।
चलो I'll teach this to you after class, ठीक है? आपको अलग से सिखाऊंगा मैं। Everyone tell me the answer. Tell me the answer. वंदना, सोच मैंने क्या बोला? रेंज के साथ जो भी होगा पावर के साथ उसका क्या होगा? स्क्वायर होगा। ये मैंने बोला था, ये आपको
हाँ।
समझ आया था? अब
हाँ।
सोच वंदना, लॉजिकली सोच। इधर ध्यान सुन, इधर दे, इधर ध्यान दे। लिखना छोड़, लिखना छोड़, मेरे को ध्यान दे। अगर तू रेंज बढ़ाएगी तो पावर कम होगी या बढ़ेगी?
बढ़ेगी।
बढ़ेगी ना, सिंपल सी बात है, ठीक है ना? मैंने आपसे क्या पूछा? अब आपकी मान ले 100 मीटर की रेंज है, ठीक है? उसके लिए आप इतना पावर दे रहे हो। अब आपने मेरे को एकदम सही जवाब दिया था, अगर आपने उसको 200 मीटर कर दिया तो आपको पावर कितने गुना
4 टाइम्स।
समझ आया? तो इसीलिए अगर 100 वॉट अगर मेरे को इसके लिए चाहिए, इफ आई नीड 100 वॉट फॉर दिस, और मैंने इसकी रेंज क्या की, 100 से 200 कर दी, तो मेरे को इसकी पावर 4 गुना करनी पड़ जाएगी। करेक्ट?
हाँ।
4 क्यों वंदना? क्योंकि 4 मैंने इसको क्या किया, 2 गुना किया ना। इसका स्क्वायर करो, 2 का स्क्वायर कितना होता है? 4 होता है। अब मैंने आपसे क्या पूछा वंदना? आपसे मैंने नेक्स्ट क्वेश्चन पूछा कि मैं रेंज को 3 गुना करना चाहता हूं, तो मुझे पावर कितने गुना करनी पड़ेगी वंदना?
थ्री बाई फोर।
नहीं, 3 स्क्वायर टाइम्स। अगर मैं रेंज 3 गुना कर रहा हूं तो मुझे पावर 3 स्क्वायर टाइम्स करनी पड़ेगी। समझी नहीं समझी? रेंज 2 गुना हुई तो पावर मैंने 4 गुना की, 2 स्क्वायर्ड।
हाँ।
अगर रेंज 3 गुना हो गई, अगर मैं चाहता हूं मेरी रेडियो वेव इसमें से जो जाए, वो जो 100 मीटर जाती है वो 3 गुना और आगे जाए, तो मुझे पावर भी ज्यादा ही देनी पड़ेगी। कितने गुना ज्यादा देनी पड़ेगी? 3 स्क्वायर टाइम। 3 स्क्वायर कितना होता है वंदना?
9।
वेरी गुड। तो इसका आंसर क्या आएगा? इससे पावर इसकी 9 गुना, तो 900 वॉट। जी
हाँ।
अच्छा, अब चल ये वाला बता। 100 नॉटिकल माइल से 400 नॉटिकल माइल कितने गुना हो गया रेंज?
4 गुना।
तो पावर कितने गुना होगा वंदना? 4
स्क्वायर।
वेरी गुड। 4 स्क्वायर कितना होता है?
16।
वेरी गुड। तो 1600 बोल सकता हूँ मैं इसको। 100 का 1600 हो गया, 16 गुना। इतना आसान है वंदना, देख समझ आ गया आपको? भूलेगी अभी? इसको रिवाइज करना।
नहीं।
इसमें दिक्कत है ना आज समझने में, इसको रिवाइज करना आज जाके। कल मैं पूछूंगा ये।
अभी समझ में आ गया।
देख अब ये क्यों, ये एक्स्ट्रा में करके क्यों सिखा रहा हूँ? क्योंकि लोगों को क्या लगता है, अगर मैंने, लोगों को लगता है दैट पावर इज डायरेक्टली प्रोपोर्शनल टू रेंज। रेंज अगर 2 गुना बढ़ाऊंगा तो पावर भी 2 गुना बढ़ेगी, लोगों को ऐसा लगता है। लेकिन नहीं, ऐसा नहीं होता है।
4 गुना।
रेंज को 2 गुना करने के लिए हमको पावर बहुत ज्यादा बढ़ानी पड़ती है, स्क्वायर गुना बढ़ानी पड़ती है, 4 गुना। समझी?
या
वेरी गुड। ऐसे डाउट हो ना, पूछा कर मुझसे कि सर मेरे को बिल्कुल नहीं समझ आया। अभी समझ आ गया ना?
हाँ
Everyone understood this? No doubts? No doubts? That is all for today. Surface waves. थोड़ा मैं और करवाऊंगा, little bit more onto surface waves, but I will teach that with the class tomorrow. Okay? That is all for today.